Let's take a look at Unit 1. Now, first thing I'm going to be taking a look at is some inequality symbols and equality symbols. So, equality and inequality symbols. You can read my writing. Our first one is one we're seeing pretty often. This is the equals. So this says is equal to. This symbol right here is less than. This same symbol with the line underneath it is less than or equal to. This one is a greater than. And this one is greater than or equal to. There we go. Now, oftentimes we use something called a number line to help us figure out which number is larger. Number line has 0 here, and then it goes up like this. 1, 2, 3. You can have decimals too, but we'll talk more about that later. And then as it goes this way, be -1, -2, and -3. And as the numbers go to the right, they're larger. So if I look at this, 3 is larger than 1. And -1 is larger than -3. So it's kind of weird on the negatives. Kind of throws people. But you just have to keep that in mind. If you lived in a real cold state, -1 is warmer than -3. If you're in the hole at your bank, then -1 is better than -3. Let's take a look at our first problem. It says use the symbols equal to, greater than, less than, greater than equal to, or less than or equal to complete the number statement. There we go. Okay, so we got 3 blank 7. Well, 3 is obviously less than 7, so our answer would be less than. Not less than or equal to, just less than. And our next one, -4 and 2. If I looked at what symbol to put here, -4 is less than 2. Probably should have did one that wasn't less than, but that'd be our answer. If I had like a 5 here and 3 here, well, 5 is greater than that, so this would be a greater than symbol. This next one has some words in it. So let me scroll down here. We got 5 dimes, and we're comparing that against 2 quarters. Well, 5 dimes is 50 cents. We put them in a common unit measure, and 2 quarters is 50 cents. So the symbol that goes here is equals to. Now these next problems deal with addition. And there's really no steps involved there. You just do it. So I got 8 plus 12 plus 31, and I want to add those together. Usually a vertical format's the best. So I'm going to have 31, 12, and 8, and then plus here. And I line them up such that see how these all lined up in the same column. I don't want the 8 under the 3 and 1. So I add these together. 8 plus 2 is 10, plus 1 is 11. So I put 1 here, and then I carry the 1. And then we got 1 plus 3 plus 1 is 5. So her answer would be 51. Let's see. We got 5 plus 293 plus 79. Now usually the one with most digits I put up on top. So I put 293 next. 79 has 2 digits, so I put that next. Notice how I'm lining up the rightmost digits. And then 5 down here. You don't have to do that, but I think it works out pretty good if you do it that way. Now add these together. 3 plus 9 is 12, plus 5 is 17. So I put the 7 here, and I carry the 1. Let's see, 1 plus 9 is 10, plus 7 is 17 again. So put 7 and then carry the 1. Then 2 plus 1 gives you 3. So our answer would be 377. Let's see, the next one, we got 512 plus 273 plus 1,234. So I'll put 1234 here. It's 1 to 4 digits. Doesn't matter which one I put next. 512, I guess. And 273. And I add these together. So I add the rightmost digits. 4 plus 2 is 6, plus 3 is 9. 3 plus 1 is 4, plus 7 is 11. So I put 1 and carry a 1. 2 plus 1 is 3, plus 5 is 8, plus 2 is 10. So I put a 0 and I carry the 1. And 1 plus 1 gives you 2. So that'd be your answer. I don't have any of these worked ahead of time, so hoping I don't make a math error in the video. That'd be bad. But it does happen. So your best case in real life, but they do want you to know how to do these by hand. Your best case is use a calculator. You don't want to screw up somebody's medications because you didn't carry a digit. Okay, so this next one says find a sum. Intake is measured in cubic centimeters, cc's. Intake involves oral ingestion of fluids and semi-liquid food, intravenous feedings, and tubal feedings. Find the total intake for the following patient for a day. So we want to add these together. Got 273, 132, 301, 413, 510, 272, 603, and 323. Running on assumption I wrote them all down correctly, let's add these together. Let me double check that. 273, 132, 301, 413, 510, 272, 603, 323. Okay, I'm going to add rightmost column. 3 plus 2 is 5, plus 1 is 6, 9, 11, 14, 17. Let's put 7, carry the 1. Let me double check that. 5, 6, 9, 10, 11, 14, 17. Okay. Now I add this column. 1 plus 7 is 8, 11, 12, 13, 20, 22. So put 2 and carry the 2. 8, 11, 12, 13, 20, 22. Okay. And then add this column. 2 plus 2 is 4, 1 is 5, 8, 12, 17, 19, 25, 28. No use to carry anything because we're at the far left column. 12, 17, 19, 25, 28. Okay, so that'd be our answer. Now, next thing we're going to look at is subtraction. So I got 842 minus 21. Now again, we put the larger number on top and the smaller one down here, but we want to line up the rightmost digits. And you subtract them. 2 minus 1 gives us 1. 4 minus 2 is 2, and then 8 just carries down, because 8 minus, there's nothing here, so 8 minus nothing is 8. So that'd be our answer. Let's look at this one. 1002 minus 873. Okay. So we'll start with the rightmost column. 2 minus 3, I can't do that, so I need to go borrow. 0, I can't borrow anything from. Here, I can't borrow anything. I'll go over here. And I borrow 1 from here. So this reduces this by 1, so this becomes 0. This would then become 10. But that's not where we need it. We need clear over here, so I'm going to cross that out. and borrow 1 from it, and that becomes 9, and then this becomes 10. And then borrow 1 from that, that becomes 9, and this becomes 10. And now that I'm doing this, I want to make that big so you can see it if you're not used to this. So let me start over. 1002 minus 873. Okay. Again, I can't subtract 3 from 2, so I come over here to borrow. So I borrow 1 from that, and that becomes 0, reduces by 1. And then you put a 1 here. So this is 10, but I need to borrow 1 from that. So I cross that out, that becomes 9, and I put a 1 here, and this becomes 10. But I need to clear over here, so I borrow again. So I cross that out, that becomes 9, and then I put a 1 here. So this is now 12. Well, 12 minus 3 gives us 9. 9 minus 7 is 2. 9 minus 8 is 1, and that's 0, so that drops away. So our answer is 129. Excuse me. One more subtraction, and then we'll get into multiplication. We got 5821 minus 87. Let me make that a little bit big again. Okay. 5821 minus 87. Well, I can't subtract 7 from 1, so I need to go borrow. So I come here, borrow 1 from that. That reduces it by 1, and then I put a 1 here, so that's now 11. 11 minus 7. You always put a 1 there, and then whatever digit's here, if this was a 3, this would be 13. Anyway, this is 11, so 11 minus 7 is 4. Then I come over here. I can't subtract 8 from 1, so I need to go borrow again. So I come over here, reduce this by 1, and then I put a 1 before this. So this is 11 again. 11 minus 8 gives us 3. And these two just carry down because there's nothing below them to subtract. And that would be your answer. Now let's look at multiplication. We got 90 times 3. Well, we'll start with the 3 here and multiply times the first digit up here. So we take 3 times 0, gives us 0. And then we go to the next one. 3 times 9 gives us 27. So that'd be your answer. Trying to think if I want to save this or not. Yeah, let me save it. Unit 01, page 1. Okay. Let's look at another multiplication one. And 417 times 51. Now we start with our first digit, the one furthest to the right. So we'll start with the 1, and we'll multiply times everything up here. So 1 times 7 is 7, 1 times 1 is 1, 1 times 4 is 4. Then, depending upon who taught you multiplication, I was taught to put a 0 placeholder here, because we're no longer in this first place. We're now over to the second place. So I'm going to take 5 and multiply times everything up here. Well, 5 times 7 is 35, so put the 5 here, and I'll carry the 3. 5 times 1 is 5, plus the 3 gives you 8. And then 5 times 4 gives you 20. So again, I put a 0 here because I want to start, like here's where my digit is. You always want to start your first one right below it. 5 times 7 is 35, put the 5, carry the 3. Then you do 5 times 1, and then you add the 3. You get to 8. Then 5 times 4. Now you add these together. So that gives us 7. 5 plus 1 is 6. That's 12. Put the 2, carry the 1. So this gives us 1. And that'd be your answer, 21,267. One more multiplication. Got 5,281 times 45. Again, I'm going to start with this digit here. 5 times 1 is 5. 5 times 8 is 40, so I put the 0 here and I carry the 4. 5 times 2 is 10, and then I add the 4, which gives us 14, so I put the 4 and carry the 1. 5 times 5 is 25, plus 1 is 26. Now I'm working with this digit, so I'm going to put a 0 placeholder here. 4 times 1 is 4. 4 times 8 is 32, so I put 2 here and I carry the 3. 4 times 2 is 8, plus 3 is 11, so put a 1 here and carry a 1. And 4 times 5 is 20, and then plus 1 gives us 21. Let me double check my math here. 0, 4, 10, 14, 25, 26, okay, 0, 4, 2, 3, 11, 1, yeah. Then you add these together. 5 plus 0 is 5, 0 plus 4 is 4, 4 plus 2 is 6, 6 plus 1 is 7, 2 plus 1 is 3, and this is 2. So our answer would be 237,645. Well, next topic we're going to talk about involves prime numbers. If you got a prime number, the only factors, we'll talk in a minute about what a factor is. The only factors are 1 and itself. I'll give you an example. If I have 10, for example, and I want to write as a product, I can rewrite 10 as 2 times 5. Now, a little dot in there means multiplication. This means to write as a product, which is to factor. And it's a little bit complex. It's like a verb. It's an action you're doing. These right here are called your factors. Noun. If it's been a long time since I've had English comp, but I'm pretty sure that's right. Obviously, this is not a prime number because this says prime numbers. The only factors are 1 in itself. This is 2 times 5. We can also write it as 1 times 10. But we obviously have other factors. Well, some prime numbers that you'll be using are 2, 3, 5, 7, and 11. There's a lot more than that, actually an infinite amount. But you'll find that most of mathematics revolves around those first 5. Occasionally it goes higher and you get into 13, 17, and so forth. Let's take a look at this next problem. It says, write the prime factorization of 24. So we want to break this down such that we rewrite as this times this times this, with everything being prime. Well, how we do this is we do it with a tree. And I'll start with 24 and put lines down like that. And I start with my first prime, the 2. And you ask yourself if it's divisible by 2. Now, when I say it's divisible by 2, can you think of something times 2 that would give that to you? Well, 2 times 12 would give that to us. Now, 2 is prime, so we're going to circle it. That piece is done. Then we go to the 12. We're still on our first prime, which is 2. And you're asking yourself if it's divisible by 2. And again, can you think of a number that you can multiply times 2 that would give you a 12? Well, 2 times 6. 2 is prime, so we circle it. And now I'm on to the 6. I'm still on my first prime, 2. You think of, is there something I could take times 2 that would give me 6? Well, 2 times 3. So for this particular problem, our prime factorization would be 2 times 2 times 2 times 3. 2, 4, 8 times 3 is 24. All of these are prime. So that's the prime factorization of that problem. And should get that up a little bit higher. Okay. Now let's look at 60. Again, I'm going to start with my first prime, 2. You think of what times 2 gives you 60, and that'd be 30. Then 30, or this is prime, so I circle it. 30 is 2 times 15. Now I'm on to 15, and I try to think 2 times something. 2 times 6 is 12, 2 times 7 is 14, 2 times 8 is 16. I can't multiply 2 by anything to get this. So I go to my next prime, the 3. And you ask yourself if 3 times something gives you that. And actually, 3 times 5. Both of those are prime, so I circle both of them. So 60 would be 2 times 2 times 3 times 5. We're just doing all the numbers we circled here, and that's our prime factorization. This is used in working with fractions in case you're wondering where we're headed with that. Let's take a look at 72. Again, I'm starting my first prime, 2. 2 times 36 gives us 72. 2's prime, so we circle it. 36, 2 times 18 will give you that. So circle the 2. Still on the 2's. 2 times 9 will give you the 18. So now we can't use 9 because that's not prime. That's not in our list. So, but it's not divisible by 2. 2 times, I can't think of anything times 2 that give that to me. So I go to my next prime, which is 3. And actually, 3 times 3 will give you the 9. So 72 will be 2 times, well, 3 2's and 2 3's. So that would be our answer, our prime factorization. Let me save that, and then we'll look at some division. And time for my tablet to blow up. Okay, bring it back up here. There we go. It's a cheap tablet, so it sometimes blows up. Let's see, we got 1,419 divided by 3. And I'm going to put it in division format since that's where we're used to. And I see if 3 doesn't go into 1. So I go to the next one, the 4. And then I can consider this as one number, 14. And I ask myself what times 3 gives us either 14 or as close as we can get to it. And that'd be 4. 3 times 4 is 12. Because 3 times 5 is 15. That goes past this. Well, whatever you put up on top, you multiply by this. 3 times 4 is 12. And then I'm going to subtract that. So 14 minus 12 gives us 2. And depending upon who taught you division, I was taught to just bring everything down so you think of it as a new problem. And notice how the 2 here is right below the 4. Well, obviously 3 doesn't go into 2. But the next one is 21. So I'm taking these two digits as a whole. 3 does go into 21, goes in there 7 times. So I'm going to put the 7 straight above the rightmost digit, the 1. 3 times 7 is 21. I'm going to subtract. 21 minus 21 drops away, and then 9 carries down. And 3 goes on 9 3 times. Now again, here's my 9. Straight above it is where I put that digit. So our answer will be 473. Let's look at the next one. $53 into 16,536. Well, 53 doesn't go into 1. If I look at these two digits, 16, 53 doesn't go into 16, so I go to 165. It goes in 165, I think, 3 times. So put a 3 above the 5, because I'm looking at 165. Well, 53 times 3, 3 times 3 is 9, 3 times 5 is 15. Gives us that. And I'm going to subtract that. Well, 165 minus 159 gives us 6. And I'll carry down the 3 and the 6. Again, I'm looking at the first two digits here, 63. 53 goes in 63 one time. 1 times 53 is 53. I'll subtract that. Of course, 6 just carries down. 3 minus 3 is 0. 6 minus 5 is 1. And then I'm looking at this because I'm now to this digit. which is straight down here. So I'm looking at 106, and 53 does go into that 2 times. 2 times 53 gives us 106, and subtract that gives us 0. So our answer to that particular problem is 312. Let's look at this next one. This one has a remainder, looks like. 5123. Okay. Look at my first digit here, 5. 5 does go into 5. So 5 times 1. So 1 times 5 gives us 5. We're going to subtract that. That 5 minus 5 drops away, and I'll carry down the 123. Now, here's the 1. If I go straight up from here, this is the digit we're working with. 5 does not go into 1, so we put a 0 here. If I look at the 12 now, 5 does go into 12. 5 times 2, well, I shouldn't say goes into it. You can come up with something. 5 times 2, so I put the 2 right above where the 12 would end. 2 times 5 is 10. Subtract that. It gives us 2, carry the 3. And again, I'm looking at this as 23, so I'm going to put the number right above here. 5 goes into 23 4 times, like that, which gives us 20. Subtract that. 23 minus 20 gives us 3. And this is our very last digit. If I kept going with this, I'd have decimals, which we haven't covered yet. So our answer would be 1024 with a remainder of 3. That. Now the next one talks about solving equations. And pretty much for the healthcare, your equations are fairly basic, not like some of the more complex ones you see in college algebra. So I'm going to modify this a little bit from what I normally put down in college algebra. We have a note at the top. It says at any step, combine numbers. Now our first step, well, my first step in college algebra is normally get rid of parentheses. You shouldn't have any parentheses in this, so I'm going to bypass that one. Second step, get rid of fractions. And for the equations we're going to see in this class, we'll multiply by the denominator, if there is one. And we'll talk about what a denominator is when we run across it in examples. Now, third step is get everything with an x on one side, numbers on the other side. And step 3, divide both sides by the number in front of the x. So let's look at the next problem. 20. It says solve for the unknown number. It says 53 plus blank equals 84. Well, where the blank is, I'm going to put an x in. X is a variable. It represents a number we don't know. So we're trying to figure out what to multiply or what to add to 53 to give us 84. Now, don't try to do this in your head. A lot of these you can do in your head. The idea is to get these steps down. Well, first step, get rid of fractions. Don't have any. Second step, get everything with an x on one side, numbers on the other side. I'm going to take this 53 and move it to the right side. If I do that, then I'll have everything with an X on one side, numbers on the other side. Now when I move anything across my equals, my sign changes. So 53 becomes a negative 53. My note at top says any step combined together numbers. 84 minus 53 gives us, what is that, 31? And actually we just solve for X. We don't have to do anything else. So 31 would be our answer for that problem. Let's look at another problem. It says blank equals 5 plus 7. Again, where the blank is, I'm going to put an X. So X equals 5 plus 7. And this problem is pretty easy because we just use our note up at top. At any step combined together numbers, well, 5 plus 7 is 12. So 12 is our answer. Again, our goal is to get the X by itself. Now, some of you learned that different, and that's fine. Whatever way you learn it, this is fine. Number 22, we got blank plus 12 equals 43. So again, where the blank is, I'll put an X. So I got X plus 12 equals 43. Well, our first step is get rid of fractions, don't have any. Second step, get everything with a number on one side, X is on the other side. So I'll take 12 over to the right side. When you take anything across the equals, the sign changes, so the 12 becomes a negative 12. And at any step combined together numbers, 43 minus 12 gives us 31, I believe. So 31 would be our answer. Let's look at next example. Blank minus 20 equals 60. Again, I'll put an X in where the blank is, so X minus 20 equals 60. First step, get rid of fractions, don't have any. Second step, get everything with an X on one side, numbers on the other side. So I'm going to take the negative 20 and move it to the right side. Anytime you take anything across the equals, the sign changes, so that becomes a positive 20. At any step combined together numbers, our note up at top, 60 plus 20 gives us 80. So 80 would be our answer. Let's look at our next one. $50 minus blank, so 50 minus X equals 15. I'm going to do this one a little bit differently. Of course, there's no fractions, so we don't have to do step 1. Step 2, get everything with an X on one side, numbers on the other. I'm going to take the negative X to the right side. And I'm going to take the 15 to the left side. Now when I take the 15 across the equals, it becomes a negative 15. When I take the negative X across the equals, it becomes a positive X. Anything you move across an equals changes the sign. Now I didn't say which side you had to get the X on. Now I did it this way so I wouldn't have to worry about that negative in front of the X. See how X is just X now? 15 minus 15 is 35, so X would equal to 35. And I guess I'm ready for a new page, so let me save this. There we go. Let's look at problem 25. We got blank times 3 equals 99. So again, I'm going to put an X where that is. And for multiplication, I'm going to put a little dot here. Times 3 equals 99. Now usually if we have a variable, an X, and a number, we put the number first. So I'll put 3X equals 99. Now I don't have my steps up here anymore, but if we remember what they were, first step was to get rid of fractions. Don't have any. Second step was to get everything with an X on one side, numbers on the other side. Well, this 3 is right next to the X, so it's trapped with it. So everything with an X is on the left side, numbers on the right side. Last step, divide both sides by a number in front of your X. Well, the number in front of our X is a 3, so we're going to divide both sides by 3. So we got 3 divided by 3 with an x equals 99 divided by 3. Now notice over here it's like I ignore the x. I'm just dividing a number by 3. Well, 3 divided by 3 is 1. So I got 1x. And 99 divided by 3 gives us 33. Now when you have 1x, in mathematics you can always just drop the 1. So you get x is equal to 33. And that's our answer. Let's look at this one. We got 4 times blank equals 20. Again, 4 times x. Having a number right next to an x indicates multiplication, so that's saying the same thing. Equals 20. And again, we put an x in for the blank. Well, this is like the last problem we just did. First step, get rid of fractions, don't have any. Second step, get everything with an x on one side, numbers on the other. Everything with an x is on the left side, numbers on the right. Step 3, divide both sides by a number in front of your x. So we're going to divide both sides by 4. 4 divided by 4 is 1, so we got 1x equals 20 divided by 4 is 5. So and the 1 drops away, like we said in the last problem. So we get x equals 5. Now, the way you can remember this, if you don't remember those steps, is you always do the opposite operation. See how this is 4 times x? That's why we divide by 4. Okay, here we got x divided by 5 equals 10. Now, I put an x for the blank, so we got x divided by 5 equals 10. Now, if I were to write this, this would be x over 5. This is fraction form. This is how we typically write it in math. We don't leave it this way. And I want you to get used to this because we're going to use this a lot in fractions. So let's go through our steps now. First step is to get rid of fractions. We have a fraction now, and we do that by multiplying both sides by the denominator. Well, the denominator is the number downstairs here, the 5, so we're going to multiply both sides by 5. So 5 times x over 5 equals 5 times 10. Now when we do that, these 5's going to cancel, and 5 times 10 is 50. Remember what I said about opposite operation? This is division, so we'd multiply both sides by 5. So you can think of it that way too. So that'd be your answer. Take a look at the next one. We got 24 divided by blank, which is our x, equals 3. And again, I'm going to write this in fraction form because it really is easier, even though normally we hate fractions. Okay, first step, get rid of fractions. Multiply everything by our denominator. Well, here, our denominator in this case is x, so it's kind of weird, but we'll multiply both sides by x. Now when we do that, this x here is going to cancel with this x. So we got 24 equals, and 3 times x is just 3x. Now, that was our first step. Second step, get everything with an x on one side, numbers on the other side. That's done. And last step, divide both sides by a number in front of your x. The number in front of our x is a 3, so we're going to divide both sides by 3. Now, 24 divided by 3 is 8. 3 divided by 3 is 1 with an x. And like we said before, 1x is just the same as x. So our answer is 8. Now, I know that you're, some of you may be comfortable with looking at these and seeing the answer, but the idea is to get the steps down. Well, the next thing we're going to be talking about is rounding. And we have to understand some of our positions in a number. And we'll talk more about these when we get to decimals. But let's say I got 1, 2, 3, 4, 5, 6. 123,456. This right here is my ones. This right here is my tens. This one is my hundreds. This one's my 100,000. This one right here is my 10,000s. And then this one right here is my 100,000s. Most of them revolve around these first ones. Rounding. And we're going to see most of this by an example. What we do is look at the digit immediately to the right, and then if 5 or greater, then we round up. And if it's less than 5, we round down. So 5 or greater, round up. If less than 5, then round down. Well, let's see what in the world that means. Okay, so number 29. I got A, B, and C. 123, 746, and 895. And the instructions say round to the nearest 10. Well, we're looking at the tens place, which is right here, which means we look at the digit immediately to the right. Now, if it's less than 5, then we round down. What round down means is this basically stays the same, so the 2 just carry straight down, and then this becomes a 0. So it'd be 120. Now, look at this one here. Here's the tens place. I look digit immediately to the right to 6. Now, this is 5 or greater. If it's 5 or greater, that means you round up, which means the 4 becomes a 5, so you add 1 to it, and then you put a 0 here. You always put a 0 there. But you either just leave this the same, that's rounding down, or you add 1 to it, that's rounding up. Tens here would be this. So I look at the digit immediately to the right, to 5. And it's 5 or greater, so I want to round up. Well, rounding up here, if I add 1 to this, that gives me 10, so I have to carry 1 there, so this would be 90. And then, of course, I put a 0 for that digit. So our answer there would be 900. Let's look at another one. So we got 5153, 7849, and 14399. We're rounding the nearest 100. Well, the hundreds place is this digit right here, and you refer to that up above. So we look to the digit immediately to the right. Now this one is 5 or greater, which means I'm going to round up. So I add 1 to this. So that becomes 2, and the 5 just stays as is. And then there's 2 zeros here for these 2 digits. Okay, here, the 8. If I look to the immediately to the right, to 4. Now nothing else matters. We only look at that digit. This is less than 5, so we round down, which means the 8 stays the same. And of course, the 7 is already there. And then these become zeros. Hundreds here would be the 3. Look to the right. That's a 9, so I'm going to round up. It's 5 or greater. So I increase this by 1, so that becomes 4. And then 1 and 4 just stay there. And then what to the right of it is always the zeros. So that'd be our answer. And let me save that. And time for it to blow up again. Excuse me. Should add some water. Next one, we're rounding to the thousands. So we got A, B, and C. 6434, 6434, 12,533, and 25,897. Now our round to the nearest thousands. This is the ones, tens, hundreds, thousands. So here's my thousands. Look to the digit immediately to the right. This is less than 5, so I'm going to round down, which means the 6 remains as is, and all of these digits become zeros. Here's my thousands here. Look to the digit immediately to the right. It's 5 or greater, which means I round up. So I add 1 to the 2, and then, of course, this 1 just stays as is, and these become zeros. Here's my thousands here. Look to the right. It's 5 or greater, so I'm going to round up. So 5 becomes a 6. 2 just remains as is, and then these are zeros. So it'd be 26,000. Okay. Now 32 says, find a sum using estimation to the nearest dollar. So we got 32.45. This is something you do a lot in Walmart. Though usually I round up just so I make sure I have enough money. If I'm paying with cash. 53.91 and 123.51. The instructions say find a sum using estimation of the nearest dollar. Well, the dollar is right here. So I'm looking at this place. I look to the digit immediately to the right. It's less than 5, so I round down. So this just becomes 32. Now I could, if I wanted to, put the zeros here like that, but you don't have to. Again, I'm looking here and look at the digit immediately to the right. It's 5 or greater, so I'm going to round up. So that becomes $54. And here, I look at the digit immediately right, and it's 5 or greater, so I round up. So that'd be $124. So I got 32. Actually, I got 124. 32.54. 8, 10. Put a 0. Carry the 1. 3, 6, 11. 1. Carry the 1. 210. Assuming I added correctly, which is always kind of iffy. 10, 1, 3, 6, 11, 1. Okay, looks right. Now, the next thing we're talking about is the mean. And this is best shown with an example. I can write the formula down, but it's a fairly simple idea. It says find the mean or the average of 3 plus 17 plus 20 plus 48. Well, to find a mean, first thing you do is you add the numbers. So we got 3. Did I put a plus between those? I should have had commas there. Sorry about that. So commas there. So 3 plus 17 plus 20 plus 48. Well, 3 plus 17 is 20, plus that is 40, 88. Gives us 88. Now, second thing we do is divide by our count. How many numbers do we have? So count of numbers. So we're going to take that 88, and we're going to divide it by 4, since we have 4 numbers. Well, 88 divided by 4 gives us 22. So this would be our answer. Our mean is 22. Now you're used to that being written as average. Mean and average are the same name, or same thing, I should say. Well, let's take a look at finding the median. So we got 53, and good thing I have commas there, which is what they should be. 5, 17, and 33. And first thing we'll do is arrange from smallest to largest. Well, our smallest number is 5, so a range from smallest to largest. I know you can't read that very good, but 5, and then our next one is 12, then 17, then 33, and then 53. So from smallest to largest. Now, if odd, our median is the number in the middle. I kind of like how the book expresses this. They say start at your very beginning and very end, start crossing off the numbers. So cross that off, cross that off. So cross one here, then cross one here and one here. And then when you get down to here, this is going to be your answer. So for our answer for this one, the answer is 17. When I say if odd, odd count, I should say. So if odd count, then your median is the number in the middle. Well, let's look at one where we have an even count, where we have like 6 numbers or four numbers. So here we got 71, 43, 21, 53, 17, and 4. Now our first step is still the same, arrange them. See our smallest number, if I wrote that down correctly, 4, yeah. Smallest number is 4. Next one is 17, right there. Next one is 21. Next one is 43, then 53, and then 71. Now if we have an even count, 6 numbers, 4 numbers, so forth, if an even count, then average the middle 2 numbers. I can spell average. Let's see, average the middle 2 numbers. Now let's do the technique of the book. We'll start crossing off number at the beginning, number at the end. So 4 and 71. And 17 and 53. If I cross these off, there wouldn't be anything left. So what we do is we take the average of these. So we're going to take 21 plus 43, and we'll divide by how many there are, which is two numbers. See, what's that give us? 64 divided by 2, which gives us 32. So our median is 32. Let me save that. There we go. Now, this next thing is we're going to talk about is mode, and this is the value that occurs the most. Now, specifically, mode has to at least occur twice, or a number has to occur twice for it to be the mode. So let's take a look at number 36. We got 3. 4, 7, 3, 4, 7, 3, 5, 1, 8, and 3. Well, let's see. Let me do the 3s first. I got 1, 2, 3, 4 of them. So I got 4 3s. Now the 4 now. I got 1, 2, 2. 7 is my next number, I guess. I got 1, 2. My next number is 5, I guess. Looks like I just have one of those. And then I got 1, 1 and 8, so I got one of those. And 8, I got one of those. So the one that occurs the most is 3. So my mode is 3. So you just, if you can eyeball it without doing that, that's fine. You just look for the value that occurs the most. Has to at least occur twice. Now this next one's talking about the range. And so, what was that, 37? And we're given 8, 2, 10, 15, and 20. Now our range is the largest value minus our smallest value. So if I look at this one, the largest value is 20, looks like, minus our smallest value, which would be 2. So 20 minus 2 gives us 18. So our range would be 18. Now the next problem deals with Roman numerals and Arabic numerals. Roman numerals, I'm trying to see what page they're on. I should have my glasses on in the book. There's a nice table of them. They're on page 29, looks like, if my eyes are such. And they got a table that tells you what 1 is, 2 is, 3, 4, 5, and so forth. Kind of how it goes, to give you a feel for it, is when we're working with it, like 1 is just an I. And 2 would be 2 I's. 3 would be 3 I's. Now when you get to 4, you rewrite 4 as, well, 4 is like 5 minus 1. So we're going to put an I, and then we'll put a V here. Since this is 5, if your smaller Roman numerals to the left of that, then that means you subtract it. This would be 5 minus 1, or 4. And then 5 would be V. Now when we get to 6, that's VI. 7 is VII. 8 is VII. Oh, 3 of them. Now 9. We never want to put 4 of any of these. So 9 is the same as 10 minus 1. Well, 10 is x, and I put an I to the side. So IX. And they give you all that going 1 through 10. I put my glasses on, I couldn't see it. But again, 10 is just x. Now Arabic is what we work with. You know, the 1s, 2s, and so forth. So let's take a look at this problem. 38. X and then 3 I's. Well, this is the same as, now the X is larger, so that's fine, and these are smaller than that. They're right, so we're fine. This is like saying X plus I plus I plus I. Well, X, if we look in that table, is 10, plus I is 1. I is 1 there, and I is 1 there. So 10 plus 1 plus 1 plus 1 gives us 13. And that would be our answer in Arabic. Let's look at another one. We got X, V, I. Now again, the X is larger than the V, and the V is larger than the I, so that's fine. We don't have to worry anything about that subtracting business. So this is the same as saying X plus V plus I plus I. Well, X is 10, V is 5, looking at the table, and I is 1, and I is 1. So 10 plus 5 is 15, 16, 17 would be your answer. Now when you get above 30, all of a sudden they change. They're not lowercase anymore, they're uppercase. So let's look at this. D, I'm looking at this in my book. D is 500, C is 100, and L is 50. So it does go from largest down to smallest. So this one I can just simply do D plus C plus C plus L. In my table it tells me D is 500, C is 100, C is 100 again, and L we said was 50. So 500, 600, 700, 750 would be our answer. Let's take a look at another one. DIX. There's a problem on this one. D is 500. I is, and this is just 1. Remember, when you go above 30, it becomes an uppercase. So that's 1, and then this is 10. It does not go from largest to smallest. So this right here, we're going to take as a entity by itself. So this first one, D, is 500 plus, and then this will be X first, which is 10, minus this, which is 1. So 500, 10 minus 1 is 9, so that gives us 509 as our answer. Now this one wants us to put this in Roman numerals, so I got 36. Well, 36, that's like 30 plus 6, which is 10 plus 10 plus 10 plus 5 plus 1. Now remember, in Roman numerals, we don't want 4 of anything. So I don't want to put like 1 plus 1 plus 1 plus 1 plus 1. I want a 5 here. We're going to rewrite this. For 30, I don't want 5 plus 5 plus 5 plus 5, because again, we don't want 4 of anything. Well, now if I look this up, this is greater than 30, so it's going to be uppercase. 10 is X, so this would be X plus X plus X plus, and 5, if I look it up, is V. And 1 would be our I. So our answer would be X, 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 V, I. Right there. They use this in some of your apothecary, if I'm saying that correctly, calculations. If you're wondering why in the world am I even learning this. Let's save this, and let's start a new page. If I had a huge amount of money, I'd buy a good tablet that doesn't blow up every other time, but I don't, so we deal with that. 71. Well, 71. Now, I don't want 10 plus 10 7 times, because I don't want 4 of them. So, but I do got 50. If I look at my table, I got a 50, that's L. So I could rewrite this as 50 plus 21. So 50 is covered. Now 21. Well, that's 10 plus 10. And then 1 would just be 1. So 50, what'd I say? 50 is L. And 10 is X plus I. So our answer here would be LXXI. Last one. 44. Well, that's like 40 plus 4. And now 40, if I wrote that, that'd be 10 plus 10 plus 10 plus 10. I don't want 4 of anything. So instead of rewriting it that way, I'm going to have 50 minus 10. Like that. And then if I did 4 here, that'd be 1 plus 1 plus 1 plus 1. I don't want 4 of anything. So this is like 5 minus 1. So 50 minus 10. If I think what 50 is, what is 50? L. And this would be X. So that would give me my 40. Now this one right here, 5 minus 1. 5 is V, and then 1 would be that, so that'd be 4. So we got XL IV. I don't know if I got Excel in this particular computer. I do. It's kind of nice. If you come here, you got a Roman function. If you type equals and then start typing Roman, and then I put in 33, for example, it comes back and gives you the result. So let's see if I'm screwed up on. I'm not greatest at Roman numerals. Let's check this. 44. XLIV. Let's see it checks. I think you can do Arabic, maybe. Okay, now I'm lying to you. I never did, but it does do the Roman numerals, so that's kind of nice. If you got Excel, you can double check yourself on those. Now, we have sometimes have a communication problem, especially when you talk about 12 a.m. or 12 p.m. What is 12 a.m.? Is it midnight? Is it noon? What's 12 p.m.? A lot of times people just say noon or they'll say midnight just to make sure there's no. Let's see. Do you want changes to improve performance? This could be because there's not enough resources. I'm going to change it to Windows 7 Basic. Hopefully it doesn't screw it up. There it goes. Probably means I'm getting close to running out of memory, which is good. I'm just about done. Basic. Okay. But to get around that, there's military time. This is covered at the very end of this chapter. It says time and allied health. You definitely don't want to screw it up when you try and decide when to give somebody their let's and so forth. So let's look at some problems dealing with that. Number 45. We got 3:43 a.m. Now we're going from it says right to following time and universal or military time. So this is our standard time we're used to. Excuse me. And we want to put it into military time. Now if it's AM, it's easy. Basically, you just keep whatever is here. Drop colon, put an extra 0 in the front if you need to. So that would be your answer. Let's look at another one. We got 8:17 p.m. Now, if it's p.m., then you want to add 1200 to it. So we got, if I dropped colon, we'd have 8:17, and then we'll add 1200 to it. Watched any kind of military shows, you're probably used to this. So now when you're talking about it, when you tell somebody give them their pills at 8:17 and you don't specify AM or PM, this tells you exactly. Because if it's AM, it'd be 08:17 instead of 2017. Now let's look going the other way. Here we're starting with 0735. It says right to following time and standard time. So this is military time or universal time. If less than or equal to 1200, then keep the same. And add AM. So and put the colon in there. So this would be 7:35 AM. For this one, 22:35. You can probably guess what we're going to do. Since this is greater than our 1200, we're going to subtract 1200 from it. So, before we added it, so here we'll subtract 1200. So we've got 5, 3, and 0, 1. And put my colon back in there. Now, if you think about this, where this would logically be, this is a nighttime, isn't it? Here we put AM, so here we'll put PM. So 10:35 p.m. And that's actually the last material in that unit, which is probably good because my computer's probably getting ready to crash memory-wise. This has gotten kind of long, this video. I need a supercomputer, I guess. But that's Unit 1.